Our next presentation is going to be by Lorraine Manjupa, working with Dr. Max Dennis. 3D noise modeling of an urban environment, simulated and measured noise characteristics of the University of the District of Columbia campus. Okay, I will give you 2 pages when you have 2 minutes left.
Good afternoon, everyone. My name is Lorraine Manjupa, and I am a senior on the civil engineering. And today I will be presenting on 3D noise modeling and environment related and measure characteristic of the University of the District of Columbia Van Ness campus. This study was done of my research. So today my presentation will consist of motivation, background, and literature review, material and method use, the preliminary results, summary, and acknowledgement. So the motivation to conduct this study was to predict the sound propagation in urban environment because it's complicated due to geometric spreading, wave scattering, and absorption losses. And also urban environments are mainly composed of buildings leading to large scattering effects. And finally, in diffuse regime, random noise is dominant and ideal for Green's function retrieval. A medium's Green function information provide physical significance by reconstructing the sound propagation path in 2D. And the cross correlation of 2 receivers in a diffuse field is proportional to the Green function between the 2 receivers. So up to date, 2D noise maps at specific height have been used to calibrate sound pressure level and distribution in urban environment. And a major sound source in urban area is traffic noise. So Green function retrieval from traffic noise measurement have shown good results. Noise level have a vertical dimension which is neglected in conventional 2D noise maps. Also, Green function are known to translate what's happening between the sound source and the receiver. And finally, 3D models implemented have a great potential for the analysis of environmental phenomena that have vertical noise variation. So to conduct this study, we had to develop a 3D noise map which captures spatial variation in noise level in urban environment. And we had to also determine the noise field distribution and the geometric acoustic modeling. Finally, we had to determine the characteristic of the 3D model noise map with measured results. So this is the material and method used for experimental site for the University of the District of Columbia, more specifically between Building 38 and 4050 Connecticut Avenue Northwest, and also between Building 38 and 39. The simulation, we used a geometric acoustic modeling simulation, and for the experimental setup, we set up a 5-minute sound pressure level daytime measurement at each site using a NOR 140 sound pressure level instrument, which you can see. So this is how the software we use looks like. This is the 3D modeling of the University of the District of Columbia, and the software uses iSIMPAP. So we use 10 line sources with a source power of 150 decibel. We had eight puncture receiver. They all at the same X and Y coordinate, but they change in height. We set up the height to be double of each one. So the source power was 150 decibel and greater, and we had surface receiver along the building facade, and the material properties, we had 10% absorption for brown ground and building facade, and 90% absorption for rectangular enclosure walls and ceiling for air. So this is the sound pressure level local animation of the University of the District of Columbia using 150 this. So for our simulated result, we observed that at the sound pressure level change with respect to height, the higher the height, the lower the sound pressure level. So the first one is the was the was the lowest one, 1.8 meter of height, and it had the higher mid sound pressure level and so forth. And these are our experimental results, which were obtained between building 38 and 39 using the No 140. And the first two histograms are results for the 8th floor. Data were recorded on the 8th and 3rd floor. So the first two histograms represent the sound pressure level for the 8th floor. And as you can see, 8th floor had the highest sound pressure level because the range is between 65.2 and 70.9, 65.1 and 71.1. And the two histograms at the bottom represent the result for the 3rd floor. So the 3rd floor had a lower sound pressure level compared to 8th floor. So in a summary, we observe a skewed distribution for the mean sound pressure level for both measured and simulated results. And in the simulation result, we observe that the lower the sound pressure level, the less the skewness is observed. And the result also demonstrated that how physical phenomena in microscale urban environment produce histogram with various shapes. So in our future work, we will continue to evaluate and compare our simulations for real life measurement. And also, we want to use a 3D numerical model that will help us better understand the relationship between measurable characteristics of urban environment and parameters of the noise histogram. So I would like to give thanks to my mentor, Dr. Mike Finnis, someone who's a graduate mechanical engineering student, and William Davis, who's a undergraduate mechanical engineering student. Thank you. Any questions?
Are there any questions online? Anyone? Okay, well, I have a question. You talked about the line sources as being the sources of sound, right? So what does that represent? That's a model of something, right? What I mean is that you're saying there's sound inputs from these sources, right? What does that represent in the physical environment?
That represents the street from Connecticut. I can possibly reach to the microphone. It could be traffic sound.
Okay, but so then basically, in some sense, when you say a line source, then those sources of sounds are kind of being stylized, right?
Mm-hmm.
Okay. Another question is, so you mentioned reproducing or getting the noise histograms. I didn't quite understand, what do you do with the histograms?
So basically, for the histogram, we are trying to also reach shape.
The Gaussian disk,
So
yeah.
basically, the histogram help us kind of compare on the method is to obtain ocean curves. So the histogram are basically to compare what we the graph we have is the ocean model.
Are you hoping that the histogram will be a Gaussian, or are you doing some kind of fitting of the Gaussian?
Yes, it basically are trying to fit it with that.
Okay, that's fine. Yeah, that's fine. Okay, thank you. Okay, so it is now, let me just look at the time.